Hi guys. So last time we discussed about the factor theorem, and today we are going to factor this polynomial x cubed plus 7 minus 3ix square plus 12 minus 21ix minus 36i, given that this 3i is a 0. By the way, this I is an imaginary number, square root of -1. You guys know that. So, so let's solve this problem, okay? So you note back, you guys note back, if k is a 0 of fx, then x minus k is a factor, and x minus k is a factor of polynomial fx. So now here it is given that 3i is a 0, so this implies, since 3i is a 0 of fx, right? So this implies x minus 3i is a factor. X minus 3i is a factor. So now we have to find out the remaining factors. So we want to use the synthetic, and we have a 3i is a 0, so you write down 3i here. We can use synthetic here because the polynomial here is in a standard form, because the exponent of the variable is in a decreasing order. So we list the coefficient. So coefficient of x cubed is 1, and coefficient of x squared is 7 minus 3i, and coefficient of x is 12 minus 21i, and the constant term is negative 36i. Okay, so now you bring down the first coefficients. So this is 1, 3i times 1 is 3i. You combine 7 minus 3i with positive 3i, it will be 7. So 7 times 3, it will be positive 21. So 7 times 3i, it will be positive 21i. And if we combine this, then you'll get 12. And this 3i times 12, which is positive 36i. And negative 36i plus 36i is 0. So this is your remainder. This is your remainder. And you know that this is 0 means you will get the remainder 0, right? Since 3i is 0 of the polynomial, that means you will get the remainder 0. So now if you use the division algorithm, so the division algorithm tells you the dividend, which is your fx, is divisor. And you see here, your divisor is x minus 3i times quotient. So what is the quotient here? The quotient, you see the degree of dividend is 3. So the degree of quotient will be 1 less than 3, which is 2. So this 1 is going to be the coefficient of x squared, and this 7 is going to be the coefficient of x, and this constant term 12, and plus remainder, which is 0, plus 0, and you know, when we add 0, then it does not make any difference, so you can delete that. So now this is x minus 3i times x squared plus 7x plus 12. And this is the quadratic polynomial. You can factor this. It's pretty easy to factor this. So you have x squared plus 7x plus 12. And you multiply the coefficient of x squared, which is 1, with the constant term 12. The product is 12. And the factors of 12, whose sum is 7, is 4 and 3. So you can simply write down x squared plus 4x plus 3x plus 12. and from the first two terms you can factor out x, so it will be x plus 4, and from the last two terms you can factor out 3, which is x plus 4, right? And again, if you look here, this x plus 4 is common, so you can factor out x plus 4, and x plus 3 is the remaining factors. Okay, so now this is x minus 3i, and the factored form of x squared plus 7x plus 12 is x plus 4 and x plus 3. So now this is the factored form of the given polynomial. Okay, so we are done with this one, and the next one is we would like to discuss about the rational zeros theorem. Okay. So let me write down here, this is rational zeros theorem. So let me write down this statement, okay? So if P over Q is a rational number in lowest terms, and if P over Q is a zero of polynomial fx, where fx is a polynomial, with integer coefficients, okay, then P is a factor of constant term, and Q is a factor of leading coefficients. Okay, factor of leading coefficient. Okay, so let me do the problems to apply this rational zeros theorem. Okay, so let me write down the example here. So you have a polynomial function fx equals to x cubed plus you have a polynomial function fx equal to x cubed plus 11x squared plus 23x minus 35. Okay, so now you have to list the possible rational zeros. So you have to list the possible rational zeros. List all possible rational zeros. So how can you solve this problem? Well, so what you need to do is you first find the constant term. You see the constant term is negative 35. The constant term is negative 35, and you can find the factors of negative 35, right? And you know the factor of the constant term is denoted by P, so you know the factors of negative 35 is plus or minus 1, plus or minus 5, plus plus or minus 7, right? And plus or minus 35, right? So these are the P's value. These are the values of P, right? So we can write the factors P of, so we can write down it like this, the factors P of negative 35. So let me write down from here, I'm sorry. So the factors P, the factors P of negative 35 are these, okay? And similarly, you guys know the leading coefficient is 1. You guys know the leading coefficient, right? The coefficient of the variable with the highest power, right? So the leading coefficient, the leading coefficient is 1. And you know the Q denotes the factors of the leading coefficient, okay? So the factors, you can write here the factors Q of, this is my Q, okay? The factors Q of 1 are, you guys know that, plus or minus negative 1, right? So now what do you need to do? So you have to get the all possible rational zeros, you have to divide these values of P by the what? These factors of, the factors Q of 1, right? So you have to divide plus or minus 1 by plus or minus 1. You have to divide this by each of them. You have to divide each of them by plus or minus 1, okay? So what will you get if you do that? So if you divide plus or minus 1 by plus or minus 1, you will get plus or minus 1, right? The combination of P over Q, right? So you divide this by this, you will get this, right? You divide plus or minus 5 by plus or minus 1, again you will get plus or minus 5. You divide plus or minus 7 by plus or minus 1, you will get plus or minus 7. And the same thing, plus or minus 35, divide by plus or minus 1 is plus or minus 35. So these are the possible rational zero. Okay, so the possible rational zeros are this. Okay, so this is the first part. Okay, now the second part is we have to determine the rational zeros of this function. Okay, so let me erase that. So how do you find the rational zeros? To find the rational zeros, so let's do the, use the synthetic division and the remainder theorem to test the possible zeros. Okay, so let's test with possible 0, 1. Test with possible 0, 1. Okay, possible 0, 1. So you write down 1 here and you the synthetic, right? So you see this is in a standard form. The coefficient of x cubed is 1, coefficient of x squared is 11, and the coefficient of x is 23, and the constant term is negative 35, right? So you bring down the first coefficient, and this is 1. You multiply 1 with 1, you have a 1. 11 plus 1 is 12. 1 times 12, this is 12. You combine 23 with positive 12, that will give you 25, right? And 1 times 20, no, this is 35, I'm sorry. And 1 times 35 is 35. If we combine negative 35 with positive 35, you get a 0. So this is a remainder. This is a remainder. So what does that mean? So that means 1 is a rational zeros, right? 1 is a rational zeros, and so this implies 1 is a rational zero. So to find the other rational zero, so you find the quotient from here. You guys know that the quotient qx is x squared plus 12x plus 35, right? And you know how to factor it. So you have to find out the factors of 35 so that the sum is 12. So this is going to be 5 and 7, right? You can do that. X plus 7, x plus 5. You can do that. So now look here. So negative 5 and negative 7, right? It makes the quotient qx 0, right? So that means, what you can see here? So that means x is equal to negative 5 and x is equal to negative 7. They are the other possible, other rational zeros. So therefore, what you can write here? So therefore, positive 1, right, and the negative 5 and negative 7 are, these are, let me erase that one. Are rational zeros. Rational zeros of polynomial fx equals to, what is our polynomial? Is x cubed plus 11x squared plus 23x minus 35. Okay? So on the part C, we have to factor it completely, and in the part C, we have to factor fx completely. Okay? Completely. So how can you do that? Now we are almost done, because from here we know 1 is a rational zero, and from here we know negative 5 and negative 7 are rational zeros. If 1 is a 0, we know x minus 1 is a factor, and if negative 5 is a 0, then x plus 5 is another factor. If negative 7 is 0, then x plus 7 will be another factor, right? So now you multiply them. So this is the factored form of this polynomial. Okay? So we got like, this is the factored form of this polynomial. So we factor this polynomial completely. Okay? And let me do the last problem. So the last problem is, find a polynomial function. The problem is, find a polynomial function of degree 3. Polynomial function of degree 3, okay, with the real coefficients, with real coefficient, right, that satisfy the given condition. That satisfies the given conditions. Okay. Okay, so what is the given condition? The given condition is zeros of negative 1, 2, and 4, and f of 1 equals to 3. Okay, so let's solve this problem. So you know, the zeros are -1, 2, and 4. So what does that mean? If -1 is a 0, so -1 is a 0, what does that mean? That means x minus -1 equal to x plus 1 is a factor, right? And similarly, you have a 2 is a 0, right? What does that mean? X minus 2 is a factor, okay? And if 4 is a 0, then x minus 4 is a factor, okay? So now, you know, but fx is a polynomial of degree 3, right? So what you need to know here is, since fx is to be a polynomial of degree 3, is to be a polynomial of degree 3, so these are the only possible factors, you know, because it cannot have more than 3 factors. So these, or you can write down x plus 1 comma x minus 2 and x minus 4 are only possible factors. Only possible factors, right? So now fx should be in the form of a times x plus 1 times x minus 2 times x minus 4, right? Now you need to find the value of a. So you need to find the value of a, but look here, from this information you can find the value of a, right? So what is given there? F of 1. So you plug in 1 here. This is a times 1 plus 1 times 1 minus 2 times 1 minus 4, right? So what is this? So this is 2. So let's write down, this is 2, this is -1, right? And 1 minus 4 is -3, right? So if you multiply that, -3 times -1, +3, times 2 is +6. So this is +6a, right? So this is +6a, but what is given there? F of 1 equals to 3. So that means 6a equals to 3. So this will give you a equals to 3/6 equals to 1/2. Okay. So now what will be the polynomial now? So the polynomial will be fx equals to, value of a is 1/2. You plug in the value of a here, and 1/2 times x plus 1 times x minus 2 times x minus 4. Right? So you got fx equals to 1/2 times x plus 1 times x minus 2 times x minus 4, and if you simplify this, then you will end up with 1/2 x to the power 3, 1/2 x to the power 3 minus 5/2 x square, minus 5/2 x square plus x plus 4, plus x plus 4. So this is the polynomial of degree. So this is the polynomial of degree 3. Okay, this is the polynomial of degree 3. So you got a 1/2 x cubed minus 5/2 x square plus x plus 4. You just multiply these two factors using FOIL, and again the product is multiplied by x minus 4 using FOIL. Then you will get this final answer. Okay, thank you guys. You have a good day. Bye.